Hey everyone, I just wanted to send out this short video to give you some notes on exponential functions and logarithms that are going to be important to some of the questions that we see in our class. So first of all, exponentials, by that I mean functions that look like maybe we have a function in the base and then the exponent is also a function. We've seen this example before with the function e to the x itself. So e is a base, x is the exponent. So e to the x is a particular example of an exponential function. And then logarithms. So often we write something like the function y equals ln, natural log of x. So what this means is e to the power of y equals x. These two are equivalent statements. This should be reviewed. This information is coming from something that you've probably seen in a pre-calc or maybe an algebra class in high school. If you want to look up any more properties or get yourself more familiar with these functions, I highly suggest looking around YouTube or Google for just some review of logarithms and exponential functions. I'm also happy to answer any questions you have about these types of functions. Okay, so a couple other things that I want to mention are some very helpful properties of logarithms. So one property of logarithmic functions are the following. So if we have a natural log of something like a to the b, this is equivalent to b times natural log of a. So what a logarithm does is it takes anything in the exponent and it's equivalent to multiplying the log by that exponent. So this is a really, really helpful property when we're looking at a function like we see in our homework for week 7. That is question number 6, where we have a situation where our function looks like the following. So in that problem, we have x to the y plus y to the x equals x plus y. Okay, so we want to get our hands on the derivative dy with respect to x. That is y prime. So the issue that you're probably running up against is that we have x's and functions of x, because y is a function of x, in the base and in the exponent of our function. So one helpful thing that we can do is rewrite that left-hand side so that we don't have exponents anymore. So that leads us to another property of logarithms and exponential functions. We'll call this property 1, property 2. So that is, if we have a base like x, that's equivalent to e to the ln of x. Okay, so let's go ahead and see why that is the case. So a couple ways we can reason here. One thing to do is just to start with this equation and then do legitimate moves or apply legitimate operations to both sides. And then we can get an equation that we know for sure is true. Then we just step back and follow our steps backwards. And that is a way to show that the starting equation is indeed true. So let's go ahead and apply some certain operations to both sides here. So one thing I can do is take the natural log of both sides. So that left-hand side then just becomes ln of x. And the right-hand side is the ln of e to the ln of x. And now notice we can use that property 1 to pull this exponent out. So that means that right-hand side becomes the following. ln of x times ln of e is equal to ln of x. So now, what does ln of e mean? Well, just reading the definition of natural log, this ln of e means that e to some power is equal to e. And why is that? Well, that's because that's our definition of the natural log. So the natural log, the input is the answer, the output is the exponent. So if we want to know what the output is here, that is equal to whatever exponent we put on the e to output e. Okay, I highly recommend you stepping through that on your own. But one other thing just to keep in mind is that the base of the natural logarithm is e. So again, what logs do is they tell us the answer for what exponent we need for the given input. Okay, again, highly recommend you think through that on your own and let me know if there are questions on that. But what this means is that when we have ln of e, that is equal to 1. That's the big takeaway here. So that question mark is equal to 1. So that means this term here is just equal to 1. Because again, natural log of e says, well, what power do we put on e to get e? Oh, we put 1 on it. Okay, so that gives us ln of x is equal to ln of x, which is a true statement. Both the left-hand and right-hand sides are the same. So if we started with ln of x equals ln of x, which is true, then if we just made 1 equal or multiplied the right-hand side by ln of e, which is just 1, then we can throw that ln of x into the exponent here. So just walking backwards. And then from there, we can get rid of the ln on both sides to give us x equals e to the ln of x. Okay, why is that helpful? Well, let's look back at this question that we were dealing with in our homework problem. So what that means is I can rewrite x to the y as e to the ln of x to the y. And now notice that exponent, I can pull that y out of the ln, so that becomes e to the y times ln of x. And the same is true as if I start with y to the x. This is equal to e to the ln of y to the x, which is equal to e to the x times ln of y. So now that left-hand side of my starting function, x to the y plus y to the x, is equal to e to the y times ln of x plus e to the x times ln of y. And now all of this then is equal to that x plus y. Okay, so now from here, I can more easily take the derivative of the left and right-hand side. Why don't we do one of those terms together? So let's just consider the derivative of e to the y times ln of x. And we want to take the derivative of both of these terms, but let's just start here. And then I'll have you continue the rest. So here we have just a nice composition function where the outside function is e to the power and the inside function is y times ln of x. So this then becomes the derivative of the outside, which is just e to the y times ln of x, times the derivative of the inside, which is derivative of y times ln of x. I'm running out of room, so let me rewrite that a little smaller. So e to the y times ln of x times the derivative of y times ln of x. Okay, so now I just need to carry out this derivative. Notice I have a product here, so I'm going to use the product rule. So this becomes e to the y ln of x times the first, which is y, times the derivative of the second. Derivative of natural log is just 1 over x, plus the derivative of the first, which would be y prime, because y is a function of x here, times the second, so times ln of x. So then if I wanted to clean this up a little bit, we could write the following. So here we can unpack this recall, e to the y times ln of x would just be equal to x to the y, because this is e to the ln of x to the y, which is just equal to x to the y. Okay, that's just some scratch work here. So this is all equal to x to the y times y over x plus y prime ln of x. Cool. So now you can do that with that other term that we have, meaning starting with y to the x. And then from there, you can take the derivative of the right-hand side, which is the derivative of x plus y. All right. So please go ahead and rewatch this video to help these properties and steps feel a little bit more comfortable. Note that some of these properties are probably going to feel kind of familiar. Some of them might not be if it's been a while since you've seen them, and that is okay. That's what we are here to do, is to learn. All right, well, best of luck on this problem and finishing up your work for this week. Please reach out with any questions you have. Thanks for watching.